Okay, so I want you to be comfortable with the chain of events starting at food down to producing energy. So first stage of digestion is converting big molecules to small ones. Through hydrolysis, converting the ester bonds, the amide bonds, and the glycosylic linkages through hydrolysis to get down to the smaller molecules. Basically, with carbohydrates, we're going to go down to glucose. With proteins, we're going to amino acids, and the amino acids go into glycolysis. And then the fatty acids go into glycolysis as well. So stage one is just called digestion. That's going from big to small. Step two is glycolysis. It's taking glucose and converting it to pyruvate, and then pyruvate goes to acetyl-CoA. Okay, so today now we're going to take acetyl-CoA to reduced coenzymes. Okay, and that is the NAD plus and the FAD plus, so that those can then be oxidized in producing ATP molecules. And this is where oxygen is required, by the way, because oxygen gets reduced to water. That's the only part where we need oxygen in this cycle here. All right. So this is Krebs cycle. And it varies depending on what article you're reading, what textbook you're reading, et cetera. Either called citrus. It's also called the, well, it's just a lot of these. Okay, so the purpose of this is to get, now remember, a coenzyme is used if we're doing something like oxidizing something or reducing something. And something else has to be oxidized or reduced at the same time. And those are typically called coenzymes. So the purpose of the Krebs cycle is to produce reduced coenzymes. Reduce. That means you're going to have so this is the reduced version, oxidized version. So as we go through here, we're going to see that we're going to be doing a lot of stuff, but we're also going to be, the goal is to get reduced coenzymes, because that's going to then drive the last stage of this metabolism, which is to take those reduced coenzymes and generate ATP from ADP. Because as they're being oxidized, that forces the kinase reactions to build up the ADP to ATP. Okay, so let's go through these steps here. Now, the other thing I want to do is make sure you understand, as we go through the steps in this, is what's going on. Are we getting isomers being done? Are we moving functional groups around? Are we moving phosphate groups around? Just what's going on? And then we're going to develop an enzyme name for that using where did it go? This guy here. Okay, we keep coming back to this page. Now you're going to have this on your final, by the way. So don't worry about memorizing this, but you need to get used to using it. Okay. Let's see here. All right, so this is where we are right now. And we're going to be going down this path here. Okay, so this. So what's going on here? Okay, this is being hydrolyzed. So, and what are we left with? We're left with this piece here. Now, we have this guy. Now, again, this is a, yeah. It's called fun. Where'd it go? Everything disappeared. Well, I wonder if I loaded it onto. Okay. Okay, should be there now. It says energy production. Now, what I don't understand is why this is. Okay, I don't know what happened to OneNote. It just went blank, so I had to reload it. Okay, anyway, I did load these slides over. So did you find them? Okay, good. Sorry about that. Okay, so the thing about the Krebs cycle, it is a cycle. And what happens is as you come around, you meet back up at the top. And at the top, you have two molecules coming together. So you have the residual, this guy, bonding together with that. Okay, so let's compare the two. Let's look at these two. Okay, what's the difference between these two? Okay, one, we have the OH group, and we also have an extra two carbon acid on the top. Okay, so a couple things now. What happens when this goes to that? Is that oxidation or reduction? Are we losing or gaining a hydrogen? We're gaining hydrogen. That means it's being reduced. Okay. So if this is being reduced, it's going to be the enzyme is going to be ox. Remember now, when we name enzymes, the first name is the substrate. The second is what the functional group is. Okay. So this is a reductase. We're reducing. Okay. The molecule is going to be oxaloacetate. That's the substrate. And the function is reductase. Okay, so if we look at our little chart, where did the chart go? Chart is gone. Okay, here's the reductase right here. It's the reduction of a substrate. So we've taken it from a carbonyl group down to an alcohol, gaining a hydrogen, reduction. Okay, so that's the enzyme that takes us from here, from here to there. Okay, now let's count the carbons here. We have 1, 2, 3, 4, 5. Okay, so we have, oh, excuse me, 6 of them. So we have 3, 2 here. Those are the 2. And then we have 4 here, which are these 4. Okay, so we've added on a group, and we've also reduced that carbonyl to the alcohol. Okay, this is called citrate. Okay, and because it's in a alkaline environment, we name it as the salt. Otherwise, it's called citric acid. And this is where the name comes. Frequently, they'll say the tricitric acid cycle as well. The first thing we produce is citrate. Okay. All right. What do we do next? Okay, what's the difference now? Let's clean this up. Okay, so what's going on here now? Well, let's look here. We've got that hydroxyl group moves down 1. So what's the isomer that does, and what's the enzyme that does that? That's called an isomerase. So we're making isomer of the substrate. So this enzyme here is going to be citrate is the substrate. Isomerase is the enzyme function. Okay, now we're at isocitrate. Okay, so here's the first step where we lose one of the carbons, going from the isocitrate down to the ketoglutarate. Now, and again, as you're going through this, I want you to study what's going on and make sure you understand what enzyme is making that work. And I'm not talking about, sometimes the names are old names, but I want you to use the IUPAC naming system for enzymes. Okay, so right here now, let's look at going here now. What's going on? Well, let's see. We have, where do we lose the carbon dioxide? It's right in the middle. So that's carbon 1, 2, 3. That's where the carbon dioxide peels off. Now that process is what? Okay, the NAD coenzyme is gaining a hydrogen, so that's being reduced. So that's an oxidation process. So that enzyme is going to be an oxidase. Okay, so what's the substrate? Isocitrate. That's the substrate. And then the process is oxidation. So that's an oxidase. Just right here. Okay, now this is the first step where we're gaining a reduced coenzyme. This is one of the many purposes of the citric acid cycle, is to produce those reduced coenzymes. We also kick off carbon dioxide, and that's why we have hemoglobin to carry the carbon dioxide away from our body and bring the oxygen back in, which is stage 4. Okay, so now we're down here at the alpha ketoglutarate. Okay, so what's going on here now? Going from this guy to this guy. Well, let's look here. Notice CoA. I'm getting that CoA again. That's a thiol reaction. Notice the S here. Okay, so what's happening is okay, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what's going on there now? Going from here to here. What's the main thing happening? Main thing happening is we're creating that sulfur bond at the end of this acid here. Okay, a thiol is like an alcohol, so it forms a thiol ester. Okay, so this is going to be, so what enzyme would that be then? Okay. Bond formation. So we're synthesizing a bond between two substrates. And we're certainly not adding a carboxyl group, we're taking one away. So it's going to be a synthase. So, okay, our substrate is alpha keto glutarate, and the function is synthase. Substrate enzyme function. Okay. Now, I haven't talked yet about, I've talked about ATP, adenosine triphosphate. There's also one that's similar to that. It's just glutathione triphosphate. It's very, very similar as ATP. It's also an energy molecule. So we have two energy molecules, ATP and GTP. Okay, so this is one step where they're actually producing a GDP from a GDP. Okay, so what's happening here is we have this is a kinase because we're transferring a phosphate group. So this reaction here is going to be a kinase. And the substrate is going to be succinyl CoA. So succinyl CoA kinase. Again, kinases transfer phosphorus groups between substrates. Okay, and secondly, notice when we go over to here, there's no S-CoA. So that's kicked off right here. So what enzyme would do that? Well, that would be, where are we here? Oh, right here. So that's a dehydrogen. So a dehydrases. Pronouncing these things are a pain. Okay, so additionally, we're going to have a same substrate and then a did I spell it right? Okay, so now we're moving on here. We're down to 4 carbons now. Okay, now let's look at these 2 molecules here, the fumarate and the succinate. Okay, the fumarate has got a double bond right here. So we are going to basically be removing atoms to form a double bond. So that's going to be a dehydrogenase. So it's going to be the substrate is succinate. Dehydrogenase would be the enzyme. Now, again, these are the official IUPAC names. Some of the names, if you go through it, are going to have a different name because they were discovered earlier before they started using the IUPAC name. But I want to make sure you understand the IUPAC because I want you to look at what's happening to the functional groups. Is more important than memorizing the official enzyme name. And to use the IUPAC name, you have to understand what's going on functionally. Okay. So let's look at what's going on here now. So here was the old double bond, and we're adding water across it. So what enzyme that would be this guy here. Addition of a small molecule to a double bond. So that's going to be, the substrate is fumarate. And then the function is going to be synthetase. Wait a minute, synthases. Okay, so now the final step, and again, we're generating a reduced coenzyme there. Okay, so what's the difference between these two? Well, this guy goes to the carbonyl, so it's being oxidized. So it's going to be an oxidase then. What's the substrate? Malate. Malate oxidase. And then we pick up acetyl-CoA and we do the cycle again. Okay. So during the purpose of the citric acid cycle. So these are the reduced coenzymes. And we're producing a energy molecule, similar to ATP. Okay. All right. I know these molecules, I totally understand these molecules are complicated, but if you just look at the small changes each time, that's where I want you to focus. Now, there's two other teachers that teach this class, and they do the same thing when they get into metabolism. The other teacher I know that teaches this class is up at Sierra, and this is the way she approaches it as well. It's a very common technique in this strand is to look at metabolism, not from memorizing a zillion enzymes, but just looking at what's happening for each step, functionally, structurally. Okay. And then this down here actually goes into, in more detail, what's going on. But it's what we just went through. Okay. That's what I wanted to cover today. What we're going to cover on Thursday is the next stage. So we're taking those reduced coenzymes, and now we're going to use them and we're going to oxidate them. And that's what's going to drive the last stage. Now, the last stage frequently is called the electron transport cycle or the oxidase phosphorylation. There are two names. And it's the main driver. We're going to end up with 28 ATP molecules produced out of this. It's a very, very efficient process. Okay. Now, next week is it. So on Tuesday of next week, on a review. No, the test is in finals week, which is the week after. It'll be on Tuesday at, I think it was. Yeah, let's look at the final schedule. And we get 2 hours for a block. And the reason they do that is so that there's no, yeah. See, at Sierra, they overlap. They don't do that at Sierra. They don't have a finals week at Sierra either. It's weird. Days ago. Yeah, I'm behind. I'm always behind. It's a top priority. In fact, I'm going to work on that right now, actually, because we don't have very many posters being. So I'm just going to start working on that. All right. See you guys. I'm going to upload. I think you came in late. I was talking about because I got your email.
Okay.
And basically, there are no worksheets for Unit 5, but there are problems in our textbook. So I'm going to be assigning those with a key.
Okay, and you'll put the textbook questions in the files? I don't have the text, but
Do you think other people don't have the textbook as well?
yeah, I don't.
Yeah, I'll copy the questions.
Okay.
So, but yeah, because otherwise,
Yeah, that's how I remember. I really love your worksheet.
good. Good. Yeah, you're plodding right along pretty well in this class.
I'm you grade the test.
Don't forget your project.
Bring it up.
Yeah. Yeah. And see, in the state of California, they don't do pluses and minuses. So an 89.5 is an A, and so is 100. And there's a big difference between those two. But the transcripts, you don't know. And up in Washington, they do pluses and minuses, and they do decimals. There's no letter grade, you get a number. So a 3 is a B, a 4 is an A. That, so
But you're gonna upload the
yeah. Yeah.